My name is Michael Grinich. I'm the founder and CEO of WorkOS. We are a company that helps developers with authentication, identity, really all the enterprise features that you need to add to your product as you take it up market and sell it to bigger customers. But today I'm not here to talk about that. I'm here to talk about something else, this little thing called agents. How many of you are building things with AI or experimenting with AI agents today? Amazing. It's a ton of hands going up. You know what's crazy is I gave a very similar talk to this about 6 months ago, and there were like 2 hands that went up in the audience. So it feels like agents on this growth rate is starting to take over. And what I'm going to talk about here is actually security and permissions and really identity as it applies to this new world of agents and how that's different than what we've been doing in the past for people. All right, so let's jump in and get started. And I'll start here with a story. So imagine that you are building the next great LLM chatbot for your team, kind of like an internal ChatGPT that your team can use to do specific actions, can handle specific tasks, maybe answer questions. And for this example, say that it's like an AI onboarding agent. So it's helping your team with IT support. So you've hooked it up to internal systems. Maybe you're using MCP, the Model Context Protocol, or some other agent framework to connect it. And for this AI onboarding agent, you need to give it access to a production database so it can actually read data about your company and do specific actions, right? So you just connect it to Postgres or Aurora or whatever you have, just like your normal app. And a user logs in and says, OK, what should we build today? Well, let's delete some unused files to clear up some space. The LLM is like, great idea. I went ahead and deleted the production database. Not great. And this might seem like kind of a fake example or something that's hypothetical, but this actually happened almost exactly like this a few months ago on one of these new vibe coding platforms where a developer was building an app through pure prompting, chatting with one of the new foundational models. It's very smart and great at writing code, but then decided to drop the entire production database, right? So you might want to lock this down, but what about if you're connecting something like, you know how to lock down a database, maybe row-level security, but what if you need to connect it to Jira, or then connect it to Salesforce, or connect it to Slack? Where do you draw the line in terms of permissions for these systems? These AI systems are only valuable if you connect it to all your stuff, right? It can't do anything unless it's connected to all of your data systems. And at the end of the day, also, if this agent deletes a production database, who's responsible? So these are questions that are really new in the world of AI agent development. In the past, a person might have been responsible, or you could scope down privileges. But it's very different with agents. You have to give them broad access to lots of things. They have to have lots of different capabilities. And they can do stuff really quickly. The shift here is that we really need to think about agents as first-class identities. First-class identities. So not just people as identities, but actually agents in these systems as identities. And it's complicated because agents aren't just machines. There's been a lot of research and a lot of work on machine identity, doing certificate, mutual TLS. You probably all have seen systems like that. But agents kind of behave a little bit more like people. They collaborate with people in similar ways. They go use other applications like people. They might interface through an API, but they also might interface actually through like a browser. Because a lot of these products that agents will go and use maybe don't have APIs, or the API is not as natural. Imagine an API going and using something like Figma. It kind of has to go click in the UI to be able to do stuff. And so this is a major shift around how we think about identity, authentication, and really this new paradigm for both engineers building this, as well as enterprise IT, who's going to be responsible for ultimately securing this. And they're on the line. They're on the hook if things get deleted. So really what I'm going to talk about here is this problem around identity for agents, some ideas that we have around it, some things that I've seen around research. But this is, I'm just going to tell you now, it's unsolved. It is a brand new thing. And my ask to all of you is that we need to come together to work on a new standard for agent identity. OK, well, let's jump in and talk more about this. So this growing trend is really about agents interacting across different tools. They're acting on behalf of users. So agents can be standalone, kind of synthetic individuals. But really often, they're more similar to people, I mentioned. And in many cases, they actually need a different type of data access. So in some cases, you would think, let's just scope down the agent. But in other cases, you need to actually connect it really broadly to a lot of different systems. If you have like a super support agent, you got to connect it to everything for it to have the context. Really, this is about context, to be able to make decisions and do stuff. And I think the implication here is really that identity in the applications of what you're building, they need to support this machine identity, this agent identity natively. The machine-to-machine system is not a fit. And if you're thinking like, okay, maybe 6 months ago this wasn't a need, your hand didn't go up around building agents, you're not convinced, this is so powerful for new products that if you don't incorporate this way of building new applications into your workplace, you're not going to be competitive. Your products won't be able to compete the market. Someone else that's able to harness this power of agentic software development will disrupt you. So there's also, there's a lot of problems that we need to solve, but I want to reinforce there's a lot of urgency around doing this. 1 month in the AI world feels like 10 years, and it's just accelerating. So we need to quickly find solutions here. Okay, well, why is it fundamentally hard? Why can't we just adapt, some existing patterns to agents? What makes this different than maybe the previous ways that we've done authentication or identity for people, or authentication and identity for machines, machine identity? Well, the first thing is the way that agents work with these systems is headless. So an agent might need to log into a browser and do something, but it's not really clicking around and using the browser necessarily. They need to have this sort of token persistence over long periods of time, long periods of invocations. You don't want an agent needing to sign in every single day. I think the joke is always about single sign-on. You have to do it every 24 hours, right? Agents, you need it to be long-lived and durable. And so we can't just adapt the existing patterns around sessions or identity to agents. We actually have to do something that's going to be a long-lived credential. And we need to be able to verify that it's authentic over this period of time without a login page. It's kind of like an API token. How do we do these long-lived sessions? Where do those credentials live? How do the agents store it securely? These are all questions that are not answered yet. That's one of the things that makes it hard, is agents need to operate in a way that's headless. The second, which I touched on a little bit here, is least privilege. So we all know probably this pattern, this best practice around security. It's having least privileges, taking a system and its access control and scoping it down to only what it needs. On the one hand, you want to do this, but on the other hand, if you're building an agent that needs to go off and have some cross-system access or cross-system behavior, you actually need to have sort of a most privileges. You need to actually expand it. What happens when the agent needs to do something it doesn't have a permission for? How do you escalate that? In a company, if a person does this, they would escalate it to the IT team. They would create a ticket, ask for the permission, be escalated, and then hopefully, if it's a mature IT org, that would be de-escalated at some time, right? Become an admin in a certain tool, and then have it drop down later. For an agent, you might need this to be done hundreds of times an hour. Probably can't be a manual approval flow, but still has the same need to be audited and logged and secure. So permissions here need to be dynamic, including permission escalation. Least privileges model is really about static permissions, not about dynamic permissions. So that's another thing that makes it hard. Third, compliance. There's an old saying, to err is human, but to screw up 10,000 times per second, you need a computer. And I think this is the case also with agents. Who did what agent went off the rails and built a ton of stuff, exfiltrated your data. These LLM systems, there's a lot of risk in prompt jacking. People being able to take advantage of them and have them do things that are unsavory. So we talked about in terms of the privilege model, but in terms of compliance, you need to have a full, deep audit log of who did what and when. Today, audit logs are mostly around people activity, humans doing things, and there's just a limit to how many things people can do inside of a company. But as soon as you start having agents, hundreds, maybe thousands of these, it's going to get a lot more challenging. So compliance is actually, I think, one of the biggest problems that's not being discussed when people building agents. There's a lot of agent frameworks. There's a lot of new tools and techniques for this that people are giving talks around. No one's talking about compliance, but we are here. If you even think about something like a log aggregation system, like a SIM, if you've ever used something like Splunk or Panther for this, those need to be adapted to agents. So just to show you, we need to go all the way through the full ecosystem to be built for this world. OK, so those are a few things that make it challenging. Now I want to switch gears and talk about some architectural patterns that I have seen other people start building. These are really just some kind of ideas as people are thinking about identity for agents that have emerged. None of these are necessarily like standards yet. They're really just ways that people have been approaching this problem. Then they have advantages and disadvantages. I'll talk through each of them just to give you a flavor of what's out there. The four are persona shadowing, delegation chains, capability tokens, and escalation to humans, human in the loop. So let's start with persona shadowing. So what does this mean? Well, it's kind of like impersonation. So you've probably seen this with a SaaS product where you can go impersonate one of your users. You can log into the tool as them and see the product as the user would see it. But really, what persona shadowing here is about is actually giving an agent like an independent identity. So it's not acting as you. It's actually sort of a reflection of you that shadows a user. Inside of an identity system, this could be like a secondary user or maybe something like a service account that has a subset of those privileges. And what this lets a system do is sort of enforce stricter limits. And it can trace agent access to those actual agents that are doing the things versus the people. Today, a lot of agent activity, like scripts that people hack together or systems that people are using, they actually just use your identity. They'll use your actual login into these systems. And so any activity the agent does looks like it was actually you doing it. This is one step away from that, where it's kind of taking your persona and shadowing it and building sort of derived identity from it. So you still stay, if you're Matt, you stay Matt Prime, but you might have like Matt Agent 1, Matt Agent 2, Matt Agent 3. So this provides this isolation and accountability. Every action is actually explicitly tied to an agent, and it's distinct from the delegated user. The problem with this is that impersonation generally gives too much power. And if you're doing this kind of like shadowing, it's very hard to scope down the roles enough. And again, I keep going back to this, like where's the permission boundary? Too wide, too narrow, too wide, too narrow. That's the challenge of persona shadowing. But it's kind of the first one people reach for because it feels pretty natural. All right, let's keep going. 2, delegation chains. So AI agents often will call other services. So you'll have an agent that starts doing one thing, and then what it'll actually do is it'll go call out to sub-agents or connect to other systems. And the idea of a delegation chain is that there's actually a way for that identity, that agent system, to be passed from one system to another. Kind of like a credential, kind of like handing somebody your AWS badge, which you shouldn't do. But that idea of it getting passed around so other people can access things. Or handing somebody maybe your Costco membership, which you also shouldn't do. This preserves this end-to-end trust and through the context of these hops. And the design here is that this agent must actually be carrying forward the user's original authorization. So their original kind of set of permissions, they're carrying it forward step by step. And it needs to be verified by these different agents. So you kind of need like a third party that you can check the permission against. If you've ever used things like JWTs, which are cryptographically signed and have some information within, and that can be passed from different systems, you can just check the signature. The signature and date is valid. It's good to go. That's kind of a version of delegation chains. And so this is another idea that people have around identity for agents, is creating the agent, but not naming the agent itself, but giving it a credential that can then be passed around. Sub-agents are becoming a very, very popular kind of like programming model for building agentic experiences. It lets you manage context. I could give a whole talk about context management for AI systems. One of my favorite AI-based coding products actually does this, where you ask it to build something, and it says, I'm going to go consult the architect. And there's a sub-agent that acts as like an architectural consultant and then brings it back in, right? And so if you wanted this idea of having a credential that's passed around, you could do it through delegation chains. This is another pattern in bringing identity to agents. It's kind of like shadow users, or essentially shadow users kind of getting passed around. This is actually supported today in some of the things I mentioned around JWTs and some things like OIDC, OpenID Connect. It's been a pattern that's existed previously in web engineering, but being applied now for agent identity, agent engineering. Cool. 3, capability-based tokens. So previously what I was talking about was having kind of a single identity given to an agent, or a single credential given to an agent. You kind of mint it once, the agent gets it, it goes and does stuff with it. There's another way of doing this, which is giving credentials for one specific task. So you really can scope it down to a single thing that it's trying to do. It's kind of like a stamped ticket for one action. And this is like a capability-based token. An example of a capability-based token would be like, Agent X can read Bob's calendar for the next 60 minutes. That's it. So that token is not actually an identity for that agent. It's a credential that it can use to go do something. And again, the permissions are tied in to the token itself. It's kind of like a secure voucher for like one resource, or even one action. You can imagine a capability-based token being used for one API call. You get to use it once and throw it away. Maybe a payment, like a single payment link. So unlike a human, which might log in with broad permissions, an agent could be given this different capability token for each task or resource. You could even imagine a service that's vending these things out. That's saying, you want to do this thing? OK, I'll let you do it, but just once. So it lets you create this really scoped down set of privileges. These tokens can be like time-bound, they can be self-contained, they can be very easy to verify. But the problem, again, it's kind of the opposite of what I was talking about earlier. You got to keep getting them. You got to keep checking them out. You have to have a service that can keep generating these. And you sort of centralize the permission creation moment into some service that's creating these. But this is a pretty powerful pattern. I actually think this will emerge more and more within internal IT systems, where you want to have a centralized log and a centralized kind of credential management system, and you're sort of checking out the ability to do stuff. And the agents are kind of calling in. In a way, it's almost like doing a RPC. You're not actually doing the function call, the procedure call, but you're sort of getting the voucher, the token, to be able to do that. It's as good as calling the thing, right? You're getting the permission to do that one function call. Today, the tokens that exist inside of typical OAuth scopes are not this granular, but there are some examples of people kind of hacking it to do this. If you've ever OAuth'd with a service, and there's a dropdown where you can say how long the token's going to be valid, you can say forever, or you can say 1 hour. That's sort of an example of a capability-based token out in the wild. But again, with agents, because they're going to do so much stuff, we have to really scope them down. OK, capability-based tokens. The last one here, for the humanists in the room, is escalation to humans. We are still in control. If all else fails, bail out, call the human. Actually have the human give the permission check, run the inline experience of approval. This is really about approval flows. And I think this will always be part of how people bring identity and permissions and authorization to agents. Because ultimately, there will still be things that you want to be in the loop for. There will always be something that you want the agent to not do. Even if designed to do that thing, you say, confirm with me before you actually go do that. Confirm with me before you send the wire transfer, before you file my taxes, before you sell my car, or whatever, right? So human in the loop will still be a thing. And the idea here is the escalation to human can really kind of add these consent checkpoints. Now, again, the downside of this, if you have agents going out and doing everything, they can't ask you every time. And what I've seen, even in the world of ChatGPT and MCP stuff, is you get this consent fatigue. If you keep asking the user, hey, are you sure? Are you sure? Are you sure? Guess what users do? Click, 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 get out of my way. I just want to get my stuff done. Human in the loop, escalation to human becomes less effective the more it's applied. So it needs to be like the Cookie Monster says, it's a sometimes food. Don't always escalate to humans, only do it when it's important or necessary. But again, then there's the question, when is it important to loop in humans? These are all just different patterns, architectural patterns, and I think the right solution is actually combining these things together. You might have some capability-based tokens, but that capability-based token might have an attribute that requires you to be in the loop. It can initially say, hey, you're able to create the wire transfer, but to initiate it, you have to get approval from me, and there's a tag on it to be able to do that stuff. So these can be composed together to actually create the type of behavior that you want in your product. And when you're building these agentic systems, I don't think there's one size fits all. Only you can know about the right permission model, the right threat model, what the risks or concerns are, whether there will be consent fatigue or not. Maybe you don't need to worry about escalation to a human being fatigued if you're escalating it to like the head of compliance, who you know is going to take it more seriously, versus escalating it to a support rep who might just be trying to get about their job. And so really these four things combined together, I think, can give you a good foundation for how to think about building security or permissions into your own agent-based workflows. And they all kind of tie into that identity permission side. Okay, so I've given you, a few architectural examples of here. Also around identity for agents, and just generally identity and what we build at WorkOS, there are a lot of acronyms. So buckle up, we're about to enter the acronym zone of this talk. And what I'm going to talk about is actually some of these new protocols that have emerged and new emerging standards all around identity and agents. So this is stuff that's not done in the world yet. It's kind of in the proposal state. But things you might start hearing about over the next few months or the next few years as people are building more and more systems to interface with agents. All right, so here's some emerging standards and protocols. The first, not really emerging, it's our old friend, OAuth. OAuth 2 / OpenID Connect. OAuth and OpenID Connect are pretty related, kind of a superset of the protocol. But we all know OAuth, right? We've all signed in with our Facebook account somewhere, or our Google account. This has been around for quite a while. And OAuth was designed initially so that users could explicitly grant this like third-party access, limited access, without sharing passwords. At the end of the day, you don't want to give an agent a password. You don't want the password in the context. You don't want it in the agent's memory, because agents are unreliable. The LLMs are unreliable. Someone can get that password out. So with OAuth, being able to do this delegated access, being actually to kind of give this consent and approve it, is actually a pattern I've seen with most of these agent systems. If you're using one of these products like Zapier or N8N, when you're connecting all these systems together, the first way you connect these things together is through OAuth. It brings your identity from other systems into it. So to give this identity to agents is through OAuth. Now, the limitation is that OAuth was built for people. It was built for human consent. And so for an agent to try to sign in through an OAuth-based system is tough. It actually has to run a browser. There's usually a lot of machine detection. There's like automated attacks that happen on OAuth endpoints. We've actually even at WorkOS built a whole product around detecting and blocking bot abuse and fraud. So this emerges here. It's very hard to tell the difference between an agent that's trying to do something good for a user and a bot that's malicious. But OAuth is a well-loved, in some cases not so loved, protocol that can actually be adapted for identity for agentic systems. Cool. Second here is something called UMA, User Managed Access. So this is actually an extension to OAuth. And it allows a user, which is like the resource owner, to actually proactively grant another party, another person, access to a resource. And you do this through like a centralized server. So this is a way that users can kind of give consent for resources. And essentially what it's doing is, as a user, it's allowing you to set policies for what an agent can access. For AI agents, they could use this to control like what a personal assistant is able to do or not do. It's essentially taking the policy and externalizing the consent to this third-party system that's giving the grant, rather than baking it into every single OAuth consent dialogue. So to think about an example here, when you sign into something and it's like, hey, I want to connect to your calendar, connect to your Google Calendar. When you hit approve, you're giving that thing access to all of your Google Calendar kind of forever. With something like UMA, you could actually give it access to a sub-resource that could be escalated or de-escalated after that initial consent. To kind of separate the permission resource authorization step from the initial authentication authorization connection. Pretty powerful stuff. And this is, again, it's an extension to OAuth. It's already out there in the wild. It's not really used that much. There's a lot of interesting stuff that's in the OAuth specs and extensions that are sort of becoming more relevant with agents. A bunch of ideas that people had over the years that didn't really catch on, but now with agents, they're more popular. And this is one I think that has a lot of potential. So if you haven't heard of UMA, check it out. Another one, increasing our acronyms, is GNAP. Sounds very cool. The Grant Negotiation and Authorization Protocol. You can look up the RFC if you want some bedtime reading. GNAP is actually designed for dynamic negotiation of token scopes. So I mentioned this before. The previous one was about resources. It's actually the resources that it's connecting to. GNAP is actually about the scopes or claims in the token itself. So rather than resources like a document or an object or a piece of code or something, this can be about the capabilities, the kind of actions that it can take. And this actually lets the client that's interacting with it negotiate like dynamically and receive these like tailored tokens. So going back to what I was saying previously about the capability-based access tokens, this doesn't create different tokens for it. It's like the same token, but you can kind of scope it up and down. And this is a really flexible framework. I haven't really seen that many examples of people building stuff with it. Weirdly, it's like many years old. It feels like it was designed today. I think it's actually an exceptional fit for what we'll need for AI agents. It's just sort of a question whether all the people building stuff now will go back and read this, or we'll just build something new. But this is pretty fantastic. It essentially is a big improvement on this static scope model that OAuth has. And the static scopes are one of the biggest challenges, not just around agent development, but I think generally OAuth. It's a big detriment to OAuth. There's a lot of people that will go through and connect their Google account to something, for example, and forget that they connected it. It's very hard to de-escalate those scopes. You have to deactivate the whole thing. You can't escalate or de-escalate. So GNAP is a grant negotiation authorization protocol. So it's really like a dynamic negotiation protocol. OIDC-A, this is the OpenID extension for agents. Now, this is very early. It's actually in a blog post from earlier this year, a couple of people working on it. When I talked about this a few months ago, someone very angrily came up to me and told me it's not in the spec, so I shouldn't be talking about it, but I think it's really cool. It's an extension to actually OpenID Connect that's specifically built for agents. So all the stuff I mentioned earlier around OIDC not being good for people actually logging in, the kind of dynamic system, this actually is an extension that makes it possible for agents. So it's this emerging standard, and it standardizes a lot of these attributes around like the model, the provider, the version, the instance ID, all the agent systems that you would want. So it kind of brings structure to that world. I don't know the current state of it. It's actually going to make it into the OIDC stuff. But again, these are like some very good ideas to go build on top of if you're interested in extending your own OIDC framework for developers. And in particular, this actually has stuff for doing capability discovery. So one of the differences between OAuth and OIDC is you can actually have this kind of discovery step that you can see what's possible in the system. And this lets you kind of like check the permissions that might be available beforehand. So OIDC-A. And the very last one here, you've almost made it through all the acronyms, is SCP, the Secure Credential Presentation. Have any of you heard of the Verifiable Credentials Project, VCs? This is through the W3C. This is something that was kind of like the Web 2.0 era. People were really talking about it. They're really excited. It was the idea that you could have like a personal credential that's created and verified by some third party that can be, verified anywhere. So if you like went to Stanford and you got a degree, you could actually have sort of a cryptographic signed credential that you have a CS degree from Stanford, and you could show that to anyone and they could verify it with Stanford's, public key. It's really powerful. It was actually built for humans, but this is something that has a lot of potential to be applied for people. Some of the architectural patterns I mentioned earlier, you can use verifiable credentials to provide that. This can be the tokens you can pass from machine to machine because they can be verified in sort of a stateless way. There's actually an OIDC extension for this too. OpenID Connect for verifiable presentations is what it's called. So you take these verifiable credentials is actually separate from OIDC. You can put the two together. So acronym soup. There's a lot of different things. I hope this standardizes a little bit more. If I'm going to give a talk here at reInvent next year about this, it'd be nice to have like one acronym instead of 5. But that's the world we're in today. All right, well, let's talk about some industry approaches and tools next. So it's super, super early. around how actually people are building with agents. But there's an approach that we've seen, and we've actually built products around this in terms of how you can bring authentication and identity to your agentic systems. And it's a pattern that we've used for many years. It's middleware. So the idea here is really to take your application, your agent code in some way, and isolate it from these third-party systems you're connecting it to with a shared layer that's actually doing the authentication and authorization at some boundary. And this is what we've built at WorkOS. We are an identity authentication company. If you've logged into products like ChatGPT Enterprise or Claude or Perplexity, Cursor, how many of you have used Cursor? Yeah, a ton of people. We're actually running that as middleware. We're an authentication middleware system. And this same thing will work for agents. We've built a product called AuthKit, which is a full identity end-to-end package for this. And we actually have also figured out how to build a middleware system for doing authorization, fine-grained authorization. It's kind of built around some of the ideas that Google had with Zanzibar, but resource-level permissions. And so this model of like just building this kind of interface layer gives your agent developers a lot of tools and a lot of flexibility and really leverage to go build expressive applications and have their code do crazy things and call out to LLMs and have it do the reasoning, get all the benefit you have from the LLM systems, get all the juice out of that fruit, but not expose yourself to risk, not expose yourself to potential attack or issues. We've actually even built in the middleware system, I mentioned some of our fraud stuff, you can also protect your app against agents doing weird stuff. So we have a product called Radar that actually blocks like fraud and abuse and detects anomalous behavior, and we run it in the same way as this kind of application middleware. So the same patterns that we've been using for a long time for traffic, for web-based systems on the internet, we can use for agents, which is thankful. There's a lot of interesting stuff being done also around identity for agents from other vendors. I know we're at the AWS conference, but I have to say Microsoft Entra is like a really, really popular identity system that a ton of companies use. It's like enterprise identity thing. And they recently introduced Entra Agent ID. So you can think about provisioning agents coming from the human identity system. There's a lot of interesting stuff coming out of that. We're working with them to hopefully standardize on some protocols there. And then also around the industry standards for this, there's some pretty interesting stuff happening from the IGA vendors, like Conductor One. It's a pretty interesting startup if you haven't seen them. It's really used by IT for human-based kind of permissioning, and it's a very natural extension to move that to agents. So a lot of cool stuff happening in the industry. What's next? What's next for this? Going kind of rewinding back a little bit, trust used to be the barrier. It was black and it was white. You had code that was trusted, code that your team wrote, because we all know our code is not full of bugs if we wrote it. It's trusted. And then you had untrusted code, things that might have been packages, open source things downloaded from the internet. You sandbox it. You run it in some type of isolated container. You don't trust its behavior. But we really had these two different worlds, trusted versus untrusted. And this has really gone away. It's very hard now to say what's trusted and untrusted. Everything's a gray area. What is real? What is fake? How can you tell that the code that's been authored by the AI system, the agent, is actually correct or trusted or not? You can't. And the same thing is true actually with like code that's written by your humans, because humans are using AI systems to write a lot of code. So it's not just the code that's being written, it's the actual behavior of the applications and the kind of end-to-end system of how these systems work in production. And even if you can trust the code itself, these LLM systems are super dynamic. In fact, they're very, very non-deterministic. They have this like stochastic behavior, and the models are changing constantly. If you're calling out to a third-party model, it could be totally different tomorrow. And so you can't really trust anything anymore, that's what I'm trying to say. Previously, you could have some code that you would run, you'd put on a box, you'd be like, okay, I'm gonna trust it's gonna do the same thing for the next 10 years. If you're plugging it into one of these AI systems, good luck. Today's apps are primarily used, say like 95% of them is by people. If you ship a new product, if you ship a new service, your humans are onboarding it, and maybe like 5% of the traffic is like some API, some Zapier thing, maybe that connects, or some automation. If you build say a task tracking app, like a Jira or Linear competitor, mostly it's going to be people using it, and then maybe there'll be some automated things, automated bug reports or whatever, right in it. But I think that this is actually going to shift. It's already shifting, especially with things like linear, where agents are becoming actually an increasing use case here. They're going from being maybe 1%, 0%, or 1% or 5%. To some point, I think that they'll actually be like 50-50%, 50-50. And then at some point, agents might be actually the dominant set of users. There might be products that are created first for agents and second for people, that you're just as a human kind of stepping in to override the system. It's not actually designed for you. And this is a huge architectural shift around building products and services, and honestly also building companies. If we think back to the early infrastructure that was API first, companies like Stripe that launch as an API, I think that there will be companies that are agent first. They launch and provide their service not to humans, but to agents. And there'll be a whole economy around agents. This might sound far-fetched, but these things happen slowly and then all at once. And there will be actually more agents than people. People, we're pretty slow to create. Long time horizon. Agents, you can make new ones very, very fast. And so it's not hard to imagine with the 7 billion people we have in the world that there will likely be trillions and trillions of agents popping into existence, dissolving, doing tasks for us. And the way that modern products will work and the way that modern applications will leverage this will determine whether they'll be successful in the market or not. And the way that companies leverage it will determine whether they're successful and competitive or not. It's going to be really, 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 really big. Billions of people, trillions of agents, one giant problem to solve around identity and authentication. So if you're interested in this, if you have thoughts around this, or you're working with agents inside of your company, or maybe just noodling around or curious about it, I encourage you to come chat with me right now after this talk, or send me a message later. One of the reasons I'm here at reInvent is to meet folks like you and to hear about what you're all building. So hopefully we can collaborate together and build this very exciting future for AI agents and rapidly bring this world to fruition and do it in a way that's very secure and safe. Thanks so much.